The overall aim of tree improvement is to pick these good families for our orchards. Ultimately, we want a better seedling that goes in the dirt that turns into a bigger, healthier tree at the end of rotation, producing more value for Rayonier. I'm David Barker, Manager Genetic Resources, and we are in the Conesville/Pine Seed Orchard. We're here today to discuss our seed orchards and how we use them to get seed to reforest our land base. So you'll notice the very wide spacing between trees, and compared to a commercial plantation. On a commercial plantation, you're just going for lots of volume growth on an acre. Here we're looking at number of cones per acre. So we actually want the trees to be spaced as far apart as we can so that growth from a neighbor doesn't interfere with branch production for any given tree. Because we want the crowns to be as big and bushy as possible, because the more branches we have, the more cones we'll produce. So seed orchards are collections of grafted trees, and we pick these trees based on data we get from our progeny tests. Progeny test is when we take lots of different trees, cross those, then you put those out in a designed experimental field trial, and you measure them, and that's the information that goes into picking selections for orchards. What we're looking at in this genetics demo are a couple loblolly families. They're planted at the same time near the end of their 5th growing season, so they'd be 5 years old. The right-hand side, we've got a cross, a full sib cross between two very high gain parents, and next to it is a check lot, and that's something that we plant commonly through our field trials as a comparison, so we can kind of measure gain against that. What we're observing here is a pretty big height difference between our check lot and then our advanced full sib cross between these two very good high volume gain parents. We're seeing a nice difference in stem diameter as well, so we're really pushing the volume. It's a plot where we've got planted a highly susceptible to fusiform rust /pine family, and there's only one live tree left in the plot. This is the sort of thing we would see in the past if we planted something out in the woods in a very high rust hazard zone. The one next to it, obviously it's a lot better for rust resistance because we still have a stand. The benefit to Rayonier of utilizing tree genetics is improvements in the seedlings that end up in the field. Progeny tests produce information on disease resistance, stem form, as far as the straightness of the bole, and overall volume as well. So once we have that data, we can pick parents that are good for all of those traits that we care about and put those into the seed orchard via grafting. And that gets us better seedlings going out to the field for those traits that we've selected.